Hey my nuggets! So we're going to look at section 5.3 in this video, and this video is just going to look at the skills review part. So just the things that we need to know for our prior math experience to keep in the forefront of our mind as we start to work with radical equations. So I'll start by just saying, what is a radical equation? Radical equation is just an equation, so includes an equal sign when we have a variable in the radical sign. So could look like anything as long as it meets the criteria that we have a variable inside a radical sign. So this part right here is what makes this radical, along with the equation, along with the equal sign. So that's what we're looking at. So two skills that we need to remember as we work through this section. So if you have your notes, again, always with you, that will be helpful. So first thing we need to remember is that when we have a question and we've got a root sign in it, so when we have a root sign, if we say take the root of 81, we interpret that root sign, unless we're given a positive and negative in front of it, we interpret that root sign as only asking us for the principal root, so only for the principal or positive root. So if you see square root of 81 in a question, we say that's 9. That's different than if we're solving ourselves algebraically and we put on the square root sign. So what do I mean? If I had x squared equals 81 and I'm solving for x, I would say x is equal to the square root of 81, and that's when I have to say that the square root of 81 can be either positive or negative 9. So I need to give both versions of that root because 9 squared gives me 81 and negative 9 squared gives me 81. So just remembering, if we take the root of something ourselves in algebra, then we have to give both the positive and negative root. If the root is given to us in a question, then we assume it's the principal root unless we see that positive or negative number on the outside. So that's the first thing. The second thing is that we have non-permissible values or restrictions that are placed on our variable when we have root signs involved. So remembering that we can't take the square root of a negative number, so this is going to put restrictions on that the radicand has to be positive. So can't square root a negative number. We can take the cube root of a negative number. So the cube root of 8, the cube root of negative 8 is negative 2, and that's okay, but we can't take the square root of a negative number. So when we get solutions, we need to make sure that they don't include restricted values. So how do I give these restrictions when I have a root sign? So the example I give you in your notes is, if we had this radical, how could we list our restrictions on x? So to do this, we say, okay, we know that the radicand, because this is a square root, index of 2, the radicand has to be, so the radicand together is that, greater than or equal to 0. We can take the root of 0, we can take the root of any positive number, we can't take the root of a negative number, and then we're going to rearrange, so use our algebra to rearrange this to solve for x. So x greater than or equal to 0, I'm going to subtract 3. X has to be greater than or equal to negative 3. This is what we would call the restrictions on x, on our variable. We saw that a little bit in the last two sections. They would give us restrictions sometimes, and in section 5.1 we put a restriction back on our answer ourselves. So that's how we find restrictions. We take the radicand, say it must be greater than or equal to 0 if we've got a radicand of a square root, and then solve for what the restriction is on x. Next thing that we want to remember as we go through this process is that when I'm finding that restriction, especially, so in the example I gave you, had 8 minus x, when I'm finding that restriction, especially if I end up dividing or multiplying across an inequality sign. So remember that an inequality just means we include greater than, less than, greater than or equal to, or less than or equal to. So an inequality has one of those signs, as opposed to an equality in an equation where we have our equal sign. So not these guys, but if we have an inequality, greater than, shouldn't underline, but greater than, less than, greater than, equal to, less than or equal to, if we multiply or divide across in an algebraic step, that changes the sign. So it changes the direction of our inequality. So for example, if I asked you, what are the restrictions on this particular radical, we would say, okay, it's a square root, so that tells us that the radicand, and in this case the radicand is 8 subtract x, has to be greater than or equal to 0. We can't take the square root of a negative number. So negative x is greater than or equal to negative 8. I'm going to divide both sides by negative 1. As soon as I'm multiplying or dividing across an equal sign, across an inequality sign, that changes the direction of my sign. So cancels, and I'm going to have x. Now I need to change the direction of the sign. So instead of x is greater than or equal to, x is less than or equal to 8. So this would be the restriction on x. And again, third thing, we're remembering that when we multiply or divide by a negative number across an inequality, that changes the direction of the inequality. Okay, last thing I want to make sure that we talk about before we get into the example year turns for this section is the idea of extraneous roots. So we've looked at extraneous roots lots so far. So we did them when we did trigonometry. We've just did them in our work on quadratics. So we don't always accept both roots. So we need to look at the context of our original question, and when we find roots for any equation, we've got to put them back into our original context and reject anything that's extraneous. So these are often going to happen in radical equations. So we know from our previous experience when we were doing our quadratic section, if our question came from a real life situation, we would often reject the negative numbers if we were measuring something like distance. So if we were doing a distance question and we square rooted something, so we got both positive and negative 9, we would reject the negative root because we couldn't have a negative distance. That didn't make any sense. So this idea, but just combining this with the idea of restriction. So we also need to check against our restriction. So the example that I gave you in your notes that we'll work through together. So in this section, we're going to be asked to solve a lot of radical equations. So if we had the root of x plus 5 equals x plus 3, and we were asked to solve this algebraically, so if we were solving it graphically, we could just rearrange this into an equation, or we could put y1 and y2 and solve for the intersection. But if we're solving it algebraically, what would our steps look like? And we'll use this as an example for extraneous roots. So I can't solve for x until I take this root sign off, because right now x is trapped in a root. But before I do anything, I'm going to list the restrictions here. So I'm going to say, because this is a square root, that imposes the restriction that the radicand, so x plus 5, has to be greater than or equal to 0. It can't be negative. So x has to be greater than or equal to negative 5. So this is a restriction that I have. So whatever answers I get once I get the solution, I need to check and make sure don't butt up against my restriction. So let's check this out. So first step here would be to square both sides to get rid of the radical sign. So if I do it to one side, I've got to do it to the other. So squaring a square root, this is going to give me just the radicand left by itself. And then here, if you need to remember what this means x plus 3 times x plus 3. So we're using our FOIL method. First times the first, x squared. First times the second, so plus 3x plus 6x when I combine those two middle terms. And then 3 times 3 plus 9. Okay, now I'm going to pull all my like terms to one side. So I'm taking both my x and my plus 5 to the other side. So I'm going to have x squared plus 6x plus 9, subtract x, subtract 5, combine like terms, x squared, 6x minus x, so plus 5x, and then 9 minus 5 plus 4. Okay, you'll see that we've ended up with a quadratic. So in the solution, we're with a quadratic, which means this is taking us back to our strategies for solving quadratics that we just looked at chapters 3 and 4. So if we've got to do this algebraically, that means our choices are what? So this is a quadratic in standard form. We can either factor, if that's easy for us, or we can change from standard form to vertex form and then use that to algebraically solve for x. So either of those strategies would work. This looks like it's going to be easy to factor, so I'm going to factor this. So looking again, my strategy for factoring, list my factors of 4, so 1 and 4, 2 and 2, and which combination of those could give me 5x. So that would be 1 and 4 if they were both positive. So this is going to be 0 is equal to x plus 4, x plus 1, and remember, if you don't feel confident in that rearrangement, in that factoring, you can always expand this and see if you get that back if you're not confident. And we would see that we would. Once we're at this step, then we're going to use this. So we're setting each of these factors equal to 0 to solve. And that gives us x equals -4 and x equals -1. Okay, we have to check both of these roots in our original context. So we've got to check both of these. So we check against the restriction. If it doesn't fit within the restriction, then we can get rid of it right away. But we also need to plug back in and check that the left side equals the right side. So we're going to do this anytime that we are squaring a square root. So anytime we do this process, anytime in this chapter, when we're getting solutions, we're going to check and make sure that they're not extraneous. So first, let's check against the restriction. So check for extraneous roots. Okay, so against the restriction, my restriction is x has to be greater than or equal to -5. So -4, 3, 2, both of these fit within that restriction. Okay, restriction is good. Now, to also check, I need to take my original equation, so x plus 5, or root of x plus 5 equals x plus 3, and I need to check for both of the roots that I found, so both of the solutions that I found, and make sure that my left side equals my right side. If not, then I'm going to reject that root. So here I'm going to plug in -4 where I have x. 4 plus 5 equals -4 plus 3. The root of 1 equals -1. The root of 1 so the root of 1, we didn't put this root sign on ourselves, so we're assuming just the principal root. So the root of 1 we're not going to say is positive or positive or -1. We're not going to say that because this root was part of the original question we're given, and they didn't give us a positive or minus there, so we're assuming the principal root. Again, we only do this if we introduce the root sign as an algebraic step when it didn't exist previously. So the principal root of 1 is just 1 equals -1. My left side does not equal my right side, so I'm rejecting this root. So see you later, x equals -4, no dice. So we would say x equals -4 is an extraneous root. We reject it. We are not counting you as part of the solution. So let's check x equals -1. And remember, we always need to check because we have 3 possible cases. We can accept both roots, we can reject both roots, or we can accept only one root. So square root of 4 equals 2. And again, because this root sign was given to us initially in the problem, we're not going to say positive or -2. We're assuming just the principal root, so just the positive root. So we have 2 equals 2. Because my left side equals my right side, then I accept this root. So I would say the only solution to this question The only solution that we accept is x equals -1. Okay, that's everything that we wanted to review. In the next video, I'll go through the example your turns.